Alright, so this is another Chapter 9 video reassessment. Alright, the question is, or the problem is, a rotating disc that has a radius of 30 centimeters with a mass of 4 kilograms is located in place, so it's locked in place. It has a string wrapped around the disc and a block hanging from the string that has a mass of 2 kilograms. What would be the velocity of the block if it drops 3 meters? So if the block drops 3 meters. Alright, so I kind of made like a little drawing right here, pretty much what it is. So this is your disc. It's locked in right here. So all it can do is just rotate like this. And then this block right here is going to fall to 3 meters. So to this line pretty much. So it's going to fall 3 meters. Alright, so this was what was given in the equation. That's the mass of the, that's the mass of the disc, and then this is the mass of the block, and that's the radius of the disc, and that's the height, the distance it's going to fall. Alright, so we're going to get the energy initial of the whole system is equal to the energy of the final. Alright, so then we're going to have the energy of the initial is just the potential energy of the block, because the block has potential energy to fall down. And then we have kinetic translational energy because once it starts moving, the block just goes straight down, which is translational energy. And then we have kinetic rotational energy because of this disc is going to be rotating. Alright, so then the mass, gravity times height, that's the equation for potential energy. And then we have 1/2 mass velocity squared, which is translational energy. And then we have rotational energy, which is 1/2 moment of inertia times omega squared. Alright, so now we gotta kind of move some formulas around. We gotta figure out how you get I and how you get W. And then, moment of inertia and omega. Alright, so velocity is equal to radius times omega. So we can move that equation around, and we can get omega equals velocity over radius. So that's what we did right here. Next, that's what we're doing from this step to this step. We're just modifying moment of inertia and omega. So we manipulate this equation right here, and we get velocity squared over radius squared. And then we do the same thing for moment of inertia. Well, we don't do the same thing because we just plug in moment of inertia equation into the our little equation we got going over here. Alright, so this is what we end up right here. So the radius is going to cancel out. So we drop that, and then we rewrite our line, and we're going to bring the 1/2. So that's going to be 1/4 times mass, and then like I said, radius is dropped, velocity moves in. Alright, so then we're going to keep the same thing on. We're just going to take out the velocity. We got velocity squared in both of these terms, so we can take it out of the equation, and then all you got to do is subtract these right here in parentheses over, and we get velocity squared by itself. So now we have velocity squared by itself. So all we got to do is get rid of the squared, so we take the square root, and I plugged in the values for everything, and we use 9.8 as gravity. And then we end up with the velocity final 5.42 meters over seconds, because it's velocity, so meters over second. So at 3 meters, this block is moving 5.42 meters over second.